Last video. Now, you need to know how to analyze parallel circuits. Now, it's a little bit more complicated than series, mainly because of how we calculate total resistance. That was a little funky, but it's way easier, once again, as long as we use a VIR chart. So we got this chart here. Again, the way to set up the chart, VIR across the top, and then the rows underneath, you need one more row than you have resistors because we're going to put total at the bottom. So we set it up the same way, and we start out the same way we did before. We're going to start out using the stuff that we already know that we don't have to do any thinking with. Well, I already know all the resistances, 10, 2, and 1, so I can plug those in. I also know the battery voltage. That also goes down here in the total for total voltage. Now, the cool thing with parallel, remember one of the characteristics of parallel is that all of these branches, all of these resistors in the branches now have a direct connection to the battery. So that means the voltage drop across all of them is going to be the battery voltage. So in parallel, we can actually zip that 9 volts, that battery voltage, whatever it is, all the way up. So in parallel, we actually compensate for this little number right here being harder to calculate because we can start out with more than half of this thing done, and we haven't even done any thinking yet. We put the resistances in, we know that. We put the battery voltage in, we know that. And then just one step farther, I know the battery voltage has to be the same across all of them because they all have a direct connection to that battery. All right, the next step is going to be to calculate this total resistance. Now, that's the hard part of this. Remember, we add them reciprocally. 1 over 10 plus 1 over 2 plus 1 over 1. We did this calculation before. That was 1.6, and then we have to take the reciprocal of that reciprocal. 1 divided by 1.6 was 0.63. We did that before. All right. The last step is to calculate the current column. You're going to be tempted to put the same number in this column because that's what we did in series. Remember, current splits in parallel. So it's not going to be the same number. We're going to calculate this current down here first by doing voltage divided by resistance. And really, it's going to be all of them is going to be that way. All of this entire column, I equals V over R is what we're going to do. Voltage divided by resistance across the whole thing. Far as the total, 9 divided by 0.63, voltage divided by resistance, gives me 14.3 amps. 9 divided by 1 is 0.9. 9 divided by 2 is 4.5, and 9 divided by 10 is 0.9. We did all these calculations before when we talked about current and voltage in parallel. All right, so this is a VIR chart that has all of the calculations together in one place that we've already done. Now, also like a series circuit, we need to check it. So let's check the total resistance first. In series, that total resistance had to be the highest in the whole column. Well, now in parallel, we want this number to be the lowest number in the whole column. So make sure that's the case. In parallel, all the voltages need to be the same and they all need to match this battery voltage. So that battery voltage should appear in all the boxes and the current should now add up to the total. So these two columns have actually swapped places compared to what they were in series. All of these must add up to the total and I believe it's pretty darn close in this one. 4.5 plus 0.9 is 5.4. plus 9, which gives us 14.4. So it's pretty close, right? Not exactly, but again, just rounding differences, I think is what we're looking at here. We're pretty close. All right, let's do 2 more. So this one says I got 3 resistances, 20, 30, and 60 that are connected in parallel to a 90 volt battery. Like before, I just want you to practice drawing the circuit. You're going to need to draw the circuit on your homework as well. So just go ahead and pause the video and draw this circuit. All right, hopefully you drew something like this. 20 ohms, 30 ohms, 60 ohms, they're connected in parallel to this 90 volt battery. Generally speaking, you need to know it's going to be easier for you if you know that when we list resistances, we generally mean for this one to be R1, the next one R2, the next one R3, and right, R1 is the one that's closest to the power source of the battery, and they go farther away after that. So you should have something drawn like this. If you want to put the battery on the other side, that's fine. If you want to flip this whole thing 90 degrees, that's fine. There's a lot of ways you can do it as long as they are connected in parallel, and some people do this as well. Let me see if I can get my pin on here. Some people will start out by just drawing a big box around the outside and then putting these in the middle. This is a no-no, and the reason this is a no-no is because of this right here. I've shown you this before. This is a diagram of a short circuit. When the electrons get right here to this junction, they actually quote-unquote see this pathway way down at the end that has lesser resistance. Remember, electricity takes the path of least resistance. So if we do this, these electrons are just going to be rolling around the outside of this circuit right here, and they're going to completely bypass all of our light bulbs, everything that's going on here. We don't want that to happen. So you do not draw a parallel circuit with a short circuit, right? Make sure that you're forcing the electrons to go through your resistors. All right. So now I want you to just simply complete a VIR chart for this circuit. Same thing we did before. We draw the chart, VIR across the top, R1, R2, R3, and total on the bottom. Pause the video now and see if you can analyze this circuit. All right. First step, the things that we don't need to think about to put in. We already know the resistances. R1 is 20, R2 is 30, R3 is 60. Didn't need to think to do that. Battery voltage, or the power source voltage, is 90 volts. Don't worry about this plus, by the way. That's just happened to be there on the program I used to draw these. You don't need to put the plus. 90 volts goes down here. And then remember, in parallel, all the resistors are exposed to the same battery voltage. So voltage is the same all the way up in parallel, not in series. Next thing we're going to do is calculate this total resistance. Remember, you do 1 over 20 plus 1 over 30 plus 1 over 60. Here's our reciprocal sum, 0.1, if you got that right. 1 divided by 20 plus 1 divided by 30 plus 1 divided by 60. And then we have to take the reciprocal of that. 1 divided by 0.1 gives us 10. If you didn't catch that, pause the video and go back. You should have this work. You should have something like this appearing on your paper, though. See what you did wrong if you didn't get this answer. And then lastly, we're going to do the current. Remember, current is V over R. I equals V over R. So voltage divided by resistance, starting down here with the total. 90 divided by 10 is 9. 90 now divided by 60 is 1.5. 90 divided by 30 is 3. And 90 divided by 20 is 4.5. So there's our completed analysis of this particular circuit. All right, so check that one, pause the video if you need to, and see if you did that right. Let's do one more. This circuit right here, let's complete a VIR chart for this particular circuit. So you do it. You ought to know how to do this at this point. Go ahead and draw your chart, VIR across the top, R1, R2, R3, and total, and go ahead and see if you can analyze this entire circuit. All right. Let's see what you got. Resistance is first, 12, 24, and 20. Battery voltage goes here, 120. That's really the power source voltage. And then remember, 120 is the same all the way up. Next, we're going to calculate the total resistance by taking the reciprocal sum of all these, 1 over 12 plus 1 over 24 plus 1 over 20, and then getting the reciprocal of that answer. You should get 5.7 for this total. Go back and see what you might have done wrong if you didn't get that answer. And lastly, we're going to do I equals V over R for this column. 120 divided by 5.7 is 21. 120 divided by 20 is 6. 120 divided by 24 is 5, and 120 divided by 12 is 10. If we look at this, 10 plus 5 plus 6 adds up to exactly 21, so that one checks out. These are all the same, and they equal the battery voltage. And this one down here at the bottom should be the lowest number in the entire resistance column. So we did that one right. So there's our examples for series circuits, or sorry, parallel circuits.